We instantiate the monster class. What color do we want it to be? We want it to draw on its teeth. We think about the growl that it makes. Do we want to include what it eats? Well, right now that's not available, right? So when we create, the new monster, we're going to have to supply this information. Maybe if there's a constructor that will allow us to input color right off the bat, input teeth right off the bat, input the growl noise right off the bat, great. But if it's not there, then what we would do is we would instantiate the monster class, and then we would call the setters to set the color, set the teeth, and set the noise that it makes. What are we going to do if we want to include what it eats, though, right? Well, what we're going to do is we're going to create a new class. And this new class is going to start with the monster class, all right? This whole notion is called inheritance. If I go ahead and include inheritance, if I include a superclass, if you will, okay, in this case the monster class, then I can say that it is in fact a monster, but I want to be able to have a little bit of control over it. And in this case, this example here, I'm going to say that I can only have red, green, and blue monsters. So the set color method can actually be overridden. I can override the set color method by creating a new set color method in this class that is going to inherit the monster class. Okay, so now I will only allow it to set these colors, and now you can't put in a purple monster or anything like that. And when we do this, we say that this overriding characteristic has completely replaced the set color method in the superclass. All right. So hopefully this is still an overview. Hopefully this isn't confusing you guys. All right. I'm a little nervous about that because I was talking to another instructor, and he said that the folks that were coming into his class didn't know too much about objects. Well, I'm kind of hoping that you're okay with this. All right. So moving right along, we create ourselves a new monster class that uses monster. We add our own attributes if we want to, what it likes to eat, when it likes to eat. And since we changed the characteristics of that monster, we added more things to it. We have entered into the realm of polymorphism. Okay, we have morphed our monster into something new. Okay, so here are the characteristics of a class by creating a new class that extends the monster class. Okay, to include North Pole monsters, Texas monsters, monsters of the Amazon, and maybe sea monsters. All right. So now, what happens if our monster has cavities, right? The monster class is going to be the starting blueprint for the subclasses, all of them. But currently, our subclasses ignore dental health completely, okay? Well, I'm sorry, my bad. The monster class is set up so that it currently allows subclasses to completely ignore dental health. I want to make sure that if anybody decides to create a monster, okay, I want to force them to consider dental health. So the way that we do that is we create a method for cleaning teeth, and we actually don't put anything in the method. This is called creating an abstract class, if you will. Okay. If we want to deal with this, one way would be to create a method for cleaning teeth in the superclass, in the monster class to begin with. Another way would be to force subclasses to define a method for cleaning teeth, and this is what I'm interested in. I want to force these people to define a method for cleaning teeth because sea monsters may not have teeth, so there's no point in cleaning them, right? They might wash their gums, for example. Monsters that eat plants have flat teeth, so they may brush differently than monsters that have sharp teeth. Okay? So, we create what is known as an abstract class. Now, an abstract class, because the methods have not actually been implemented, it's nothing more than just the method name, like prototyping. We have to somewhere at some point write that method. Okay, and if we fail to do so, then of course we're going to have a crash. Consequently, since the method hasn't been implemented, since it's been prototyped, if you will, our monster class no longer can be instantiated. However, we can still extend from it. Okay, we say that when the monster class can no longer be instantiated because it doesn't have complete methods, we say that we have made an abstract class. All right, and in order for Java to know that it's an abstract class, we have to include the keyword abstract. Okay, so here we have monster class has been made abstract, and then we put in an abstract method, and this is the whole critter right there: abstract void brush teeth, semicolon. You'll notice there is no open curly brace, no closed curly brace, curly brace, or any code that implements this. When I extend the monster class with a subclass, you have a subclass that's going to utilize my monster class, in there right off the bat we're going to get a message that says we have to implement this brush teeth method. We have to create something, open curly brace, code, close curly brace. Otherwise this thing will not work. Okay? So the whole monster will include a class that manages maybe the arms, the number of elbows, the number of fingers, the number of fingernails, methods for how the arm works. We can include legs, the number of knees, the number of toes, how they work, which means more and more subclasses, right, in order to make this happen, because some monsters don't have legs. Therefore, they won't have elbows or fingers or fingernails, right? I'm sorry, they won't have arms. So therefore, they won't have elbows, fingers, and fingernails. We have to think about all of those things when we're actually putting together our entire model for the monster. So, do we want all monsters to have arms? Well, as I said, not necessarily. But if I want to make sure that they do have arms, then in the abstract monster class, I am going to include a method for instantiating arms, or instructions, that instantiate arms, elbows, and fingers, and that kind of stuff. Do you only want some of the monsters to have arms? In the North Pole monster, I might include those, those prototypes, if you will. In the sea monster, I'm not going to include those prototypes. So, Nippy the North Pole monster, I have some code here that basically, says I have the North Pole monster is going to extend the monster class. Here I'm going to create arms, create legs, create the fur color, and then my required method of brushing the teeth, right? And then down here I have Nippy North Pole monster some more. North Pole monster, Nippy is going to be equal to North Pole monster. And then we're going to put in all the code that we need to set up Nippy. Okay? Nippy is a composition because the North Pole monster instantiates other classes, the arms and the leg classes, in order to make this work. Okay? So within that, that object, we have at the very, very beginning, we made calls to classes where we instantiated some arms, we instantiated some legs, or whatever. Okay. We call this a composition class because if Nippy is destroyed, then any of the classes that were instantiated when Nippy was created, they will also be destroyed. Okay. If the class makes use of classes that have already, or objects that have already been instantiated. It looks out there and it says, oh yeah, there's an object out there, I'm going to bring it in here into this class, I'm going to instantiate this class into a new object which is going to utilize the stuff from that other object that I just brought in here, and I know it sounds confusing. We call that an aggregation. We call that an aggregate. Okay? So, what are some of the key terms that we're dealing with? Okay? Well, class, static, object encapsulation, very, very important, inheritance, private variables, private methods, public methods, overriding, abstract, polymorphism, and composition. So these are things to be thinking about, and hopefully this little review will help you to get your head into the game. If you didn't understand these terms, we don't really have the time, or I don't have the time to create videos to really pin all this stuff down, because that is in fact its own course. Go out on the web and look up what polymorphism is, look up what encapsulation is, look up what inheritance is. All of this stuff is exceedingly important to understand, because these principles that you're seeing right here, polymorphism, encapsulation, and all that stuff, it isn't unique to Java. It's not unique to a particular programming language such as C++ or even a body of programming code. It can be applied to XML. It can be applied to HTML. And in fact, when we're working on the Android and we're building up the user interface, you're going to see that all of that stuff comes together, and all of that stuff can be applied to areas of programming that you probably didn't realize it could be applied to. So with that, I'm going to say happy coding.